So the first thing we're going to do is go through lab 5, which is what we did in class on Friday. And basically your lab pretty much followed what you did in lab 4. However, this time you were creating an array of automobiles, right? Plus you had to create another method that iterates through your array and prints out each automobile, the two-string method of each automobile. So the first thing we need to do, of course, is prompt the user for how many automobiles they want to create. So ask them, how many cars will you have? Then create an array of that size. Next, our method, we want to call our method and iterate through that array and print out each. Actually, first, before we do that, we want to iterate through our array and ask the user to enter in the details of that car. Then create a method passing our array, iterate through that array, and call our two-string method. And we want our output to look very similar to this. So let's get started. So here I have lab 5. This basically, I copied this from our lab 4 that we did 2 weeks ago. And I have an empty main, right? I have an automobile class. It's the basic automobile class that we've been creating for a while. I have it fully encapsulated. So I have private variables and public getters and setters. Plus I have a constructor that takes in 3 parameters, all right? So inside our main, the first thing we want to do is prompt the user for how many cars they want to enter. So I'm going to go ahead and do that with a system.out. How many cars, actually think, how many automobiles would you like to enter? I'm going to use a print instead of a print line. Of course, anytime we want to read from the console, we do need a scanner. And it follows the same format that we've been doing. Remember, in NetBeans, you can do Control-Shift-I to import, or you can go over here, add import. Now that I have that, I want to read in the number of cars. Int number of autos equals input.nextInt. All right, so now I have the number of cars I want to create. So for this lab, we want to make an array of that size, but that array will hold automobiles. It will hold cars. So whenever you want to declare an array, you always start with the type. It's gonna, or whatever it's gonna hold. It's gonna hold automobiles, right? Automobile. And then brace, that signifies it'll be an array. Whatever we want to name it, cars equals new automobile. Then we pass in what the size of this array will be. All right? So now I've created an array of automobiles, of cars. Now remember, whenever you declare an array, create an array, it's always empty. There's nothing in here. So what you'll see is we have to create the cars within this array in order to actually populate it. And I'll show you what'll happen if I don't create those cars. So now we want to iterate through our array and read in different attributes of the different cars. Int I equals 0, I is less than cars dot length, I plus plus. Now I want to say system.out dot println. What is the automobile 1 make? Automobile plus I plus 1, because I starts at 0, but I don't necessarily want to say automobile 0 make. String make equals input.next. There we go. And I repeat this for model and number of doors. Model 1, number of doors, and this will be an int number of doors equals input.next int. All right, so I read in the make, I read in the model, I read in the number of doors. All right, everybody with me so far?
Yes, sir.
So I'm going to create this method now to display each automobile's information. So I gave you the method signature, public static void display details. Public static void display details. We pass in an automobile array. Again, in Java, when we pass an array, it's passed by reference. So if you remember, any variable we create in Java, anytime we create a variable, it stores some type of, or it reserves a slot in memory for that variable. When you create an array, it just stores sequential areas in memory for that array, however big your array is. If you have an array of size 100, you have 100 slots in memory, right? So if I pass this array to this method and we copied it, which would be passed by value, that could be a very intensive operation CPU-wise. What if I have an array of a million and I copied all those values? The computer would just be spending time copying, which is inefficient. So in Java, we do pass by reference for arrays and objects. We just pass a pointer, a reference to that array in memory. That way, automobiles points to the same location in memory as cars up here when I pass it. Right? So when I do this, display details, I pass in cars, it passes in that pointer to the same array in memory. In memory, you have sequential list of little data slots for your array, and cars points to that list. Well, now when I pass cars to this method, it passes a reference to that list. So automobiles also points to that same list as well. So I can use automobile in this method, just like I use cars up there. For int I equals 0, I is less than automobiles.length. I must refer to it as automobiles though, because that's my parameter for this method. I plus plus. All right. So now all I want to do is system.out.println automobiles at index I dot toString. So what I'm doing here is I'm going into my array and I'm referencing the object at index I. So I'll iterate through each object in our array and I'm calling the toString method. So I guess your next question would be, where is this toString method coming from? It's coming from our automobile class. This toString down here. So any object of this class will have a toString method, and that's what I'm calling right here. I'm calling this toString method. It should print out make or return make, model, and number of doors. Same with over here. When I system.out.println this, it should say make, model, number of doors. All right. But you'll notice an error here. So in this program, I never actually created the objects, right? The actual physical objects. I created the array and I got all of the information, but each index in this array has yet to be initialized. There's no objects in that array yet. So what we could do is this. There's a couple different ways you can do this. Automobile C equals new automobile. And when we create a new automobile, we have to call our constructor. Our constructor method takes a make, model, and number of doors. So I'll pass that. I'll pass in the make, model, and number of doors that I read from the console. Make, model, number of doors. Be mindful of your order. Order does matter, right? Whatever your order is in your constructor, that's what your program will assume is passed to it. So for example, if I accidentally swap this, or if I repeat this twice, it's going to read model, model, even though this should be make. If I swap this and I put model first, when we get to our constructor, it's going to think that's make and that's model. So make sure you are mindful of the order that you put your parameters in. All right, so here I create an object called C, right? Automobile C. Again, our cars array still doesn't have any objects in it. It's still an empty array. So what we must do is cars at index I, we can set it equal to C, which is an automobile object. Right? It's going to set a reference to that object. That's one way of doing it. Or you can do all of this in one line. You can just say cars at index I equals new automobile. And we would not have a C. Right? So I take the reference, and I take that reference and I set it equal to a new object, right? An automobile object. So let's run this. How many automobiles would you like to enter? I'm going to say 2. Automobile 1 make, Ford Escape, and it has 4 doors. Automobile 2 make, Jeep, just saw this today in the parking lot, Compass, has 4 doors. And there you go. So what happened was I read in the number of cars first. Then from that number, I create an array of that size. Next, I iterate through that array. I read in a make, model, number of doors. Then inside that array, I set each index equal to a new automobile. Lastly, I call my cars method, and I print out the details of each car by calling the toString method of those objects. Any questions? All right, there's no questions. We can move on to the assignment. So what you'll notice this semester is each assignment is very similar to the lab. The key difference is in the labs, we're doing automobiles. For the assignments, you're doing athletes, all right? So if you can get through the automobiles labs, you should be able to get through the assignments, all right? So for the assignment, what you're doing is creating an athlete class. Then same thing like the lab, we're going to create an array, read in the information for those athletes, print out the athlete information back. So we have our athlete class. I wanted to show you how I converted the int height into a 6 foot, 7 inches kind of format. So what you want to do is the user will input the height in inches, right? So that's why it's an integer. But when you come into your method or into your class, I want you to convert that height into a different format, into a string of feet, double quotation, inches, single quotation. So basically you'd have to find what the feet are and the inches and then put those into a string. So that's what I did here. Int height feet equals height divided by 12. Again, since these are integers, you're going to get a whole number afterwards. Then I use the modulo operator to get whatever the remainder is. All right. I get my height in feet, height in inches. Then I set the height in feet, height in inches, in this string right here. All right. Same thing in my set height method. I do the same thing, right, to set the string height to that format. All right. Let's go into the main. I'm going to run through this very fast. So the first thing is to create our scanner object. Scanner input equals new scanner. System.in, because we want to read from the console. Control-Shift-I. Next is to prompt how many athletes they like to create. How many athletes would you like to enter? Read in the number of athletes and number of athletes. Use input.nextInt. Create an array of athletes. New athlete of size, the number we just read in. Iterate through. Read in each athlete's information. Starting with the name, then the weight or the height, it really doesn't matter. And weight equals input.next int. And then the last thing for height. So if I'm going too fast, slow me down. But again, this is very similar to what we just did for the automobile. Then we go through our athletes array, equals new athlete, passing in the name, the weight, and the height. And I believe that's correct. Yep. All right. Lastly, we create our method, public static void display details, athletes, and I iterate through this, printing out the toString method. System.out.println athletes, and then there's I.toString. And then I call that method. All right. So again, that's what basically the same as our automobile class, automobile example. I run this. I want that up there. How many athletes? I'm going to say 2. And I don't want the output like this, so I'm going to fix that. I want this to be a print. I want these to be prints as well. All right. 2. I'm actually going to change this to a next line. Therefore, we can have a space in the name. And it doesn't work that way. So let's make this a print line. So, yeah. All right. So it's gonna. I don't feel like debugging this right now because I have other stuff to get to. But yes, I will. So let's just do one name at a time. I think she's like 165. Height. What is 5 feet 9? 69 inches. Athlete 2. Let's see. Who's out there? Federer. I have no idea. And I think he is 7'3". And there we go. It prints it out like I wanted to. All right. Any questions?
No, sir. Can you scroll? Can you go back up right quick though?
Right here?
A little further. Well, go to the athlete file.
You trying to look at this?
Yes, sir. I see it now. I'm good now.
Anybody else? No? All right. Well, let's keep going. Lecture 8. So this one should be fairly quick. Shouldn't take too long. We're just talking about overriding and overloading methods. So overriding methods, some of you may have experienced this, where NetBeans wants to say at override. Basically, if you remember, we have parent and subclass or superclass subclass relationships in Java. It's called inheritance. That's a huge concept in programming, object-oriented programming. And again, it's one of the 4 pillars of object-oriented programming. I'm going to keep reiterating these to you. One is encapsulation, which is where we have our private variables and our public getters and setters. 2 is inheritance. The next one we'll be talking about is polymorphism. And then the last one is abstraction. Okay, polymorphism I think is next class. We've been covering inheritance this past week, and today we're going to be finishing off on inheritance. So one of the key concepts in inheritance is overriding, right? Say, for example, our superclass has a certain method, and we want our subclass to alter the behavior of that method or have some type of different behavior in that method. We can override that method in our subclass, right? So again, sometimes a subclass needs to modify the implementation of a method defined in a superclass. This is called overriding, method overriding, not overloading. Some things to note when overriding. The method signature must be identical. The return type must be identical or compatible. Again, that's called polymorphism. We'll talk about that, I think, next time. Another thing, private methods from a superclass cannot be overridden, nor can static methods. Static methods belong to the class itself, not to the objects of it. Right? So when we're overloading methods, what we're really doing is overloading the methods for each object type. So let's do an example of this because it becomes clear with examples. So let's say we have a geometric object, right? Just general geometric object. It has 3 characteristics: color, field, and date created, right? This geometric object has 2 constructors. One is a default constructor with no parameters. And all we're doing is just setting the date created equal to a date, today's date. That's what java.util.date does. It gets the current date. It also has another constructor that has two parameters, color and field. And again, we're setting the date equal to today's date, and we're setting color and field equal to those parameters. Lastly, it has a toString method. So let's create that object. So again, we click on our package, new Java class, geometric object. All right, here's an empty geometric object. So it has a private date, date created. It's going to ask to import date. Click over here, java.util date. There's another one called java.sql date. We don't necessarily need that one. We have private string color. By default, it's white. Then we have a private Boolean field, right? And there is no default value right now, right? And white is lowercase. Next, our geometric object does have a default constructor, public geometric object. It's a default constructor because there are no parameters. And the only thing we're doing in this is setting our date created equal to new date. Over here, they did java.util.date, but since we imported it, we don't have to do the full name. We can just say date like that. The next one, our geometric object has another constructor with a string color and a Boolean field. We just want to pass those in to our object when we create it. Date created doesn't change. It equals a new date still because we want to set it equal to today's date. However, this dot color equals the color parameter that we pass in, and this dot field equals the field parameter that we pass in. Next, I'm going to encapsulate the fields. So refactor, encapsulate fields, select all, refactor, and now all of our fields are refactored or encapsulated. So now our class is encapsulated. We've fulfilled the requirements of encapsulation. Lastly, our geometric object has a toString method, public string toString. Tostring methods are really good when you build classes because, say, for example, I want to print out all the characteristics of your object, but I didn't code it. You coded it. I'm just using your classes in your projects. Well, if I want to print out all the details, I can just call your implemented toString method, and hopefully you've implemented it to where it returns a nice, cleanly formatted string. So that's the purpose of toString methods, and they come in handy when you're sharing your code in a large project. So we want to return all of this right here. So return created on plus date created plus new line color plus color plus, I believe, another new line, or nope, and field plus field. So this is going to return created on, then whatever date it was created. Then on a new line, it's going to say color and field, right? It's going to print out the color and if it's field or not, all right? So we've created our geometric object. Again, this is a very general geometric object. It just, it's just going to be the overall class. From this geometric object, we can create rectangles, we can create circles, we can create triangles, but we all want them to have this same general characteristics. So we move on in our example. Now we'll have a circle, right? Circle will be a subclass of geometric object. So it extends geometric object. Circle has a radius, a default constructor that doesn't do anything, and a default constructor that passes in a radius. Similarly, we have another constructor that passes in radius, the color, and the field. All right. It has a get area, get diameter, get perimeter methods, plus print circle method, and a toString method. All right. We're going to be overriding the superclass or geometric objects toString method right here. So let's create our circle class. Java class, circle. And all the circle has is a radius. Yep, double radius. Private double radius. Circle has a default constructor, which doesn't do anything, so just empty. Also has another constructor that passes in a radius and sets this dot radius equal to radius. We do need to call our super constructor, right? It also has another constructor, circle, double radius, string color, and Boolean field. So it takes in 3 parameters. We can call our super constructor, set this dot radius equal to radius. Then we could call our set color method, our setter, and our set field method, field. And I didn't think this would work. This is how they did it in the book. But obviously it doesn't work here. So what we can do is, instead of trying to call these methods, we can just do our super, passing in the color and the field. Luckily, we have that constructor. At least I thought we did. Oh, okay. All right. So this will work, but I forgot to put the extends. All right. So what I'm doing is this first constructor, I'm not really doing anything, but I do want to call, again, super. And this one, circle itself pulls in a radius. We call our super constructor without any parameters. And we set this dot radius equal to radius. This constructor, on the other hand, again, it takes in 3 parameters, 2 of which belong to our superclass. So we call our super constructor. We set this dot radius equal to radius. And then, because circle is a subclass of geometric object, we can call set color and set field, and it will refer to this circle that we have, okay? Even though those are part of the superclass, by circle being a subclass, it inherits all those methods. So we can call those methods from inside this class. We could also do it like this as well. Whatever your preference is. All right, so next I'm going to encapsulate the fields, which is just radius. Next, I'm going to create the area, which I believe returned pi r squared math.pi times math.pow radius squared. It also has a perimeter, get perimeter. return math.pi times radius times 2, which is 2 pi r. Public, it also has a get diameter, and you see our circle class, although it's a subclass of geometric object, it has many other methods as a part of it, right? And that's the beauty of subclass, superclass relationships. You can still have geometric object, take all those methods and everything, but then add your own methods into subclasses. So if I had a rectangle would have a length and a height, or width and height, right? So we can do our get area method in our rectangle class with width and height. Return 2 times radius, that's the diameter. And then lastly, we have a public string, actually public void print. And I believe the print method, the circle is created and the radius is. So system.out.println, the circle was created on plus, and I can call my get date created method from the superclass, right? And that'll refer to our circle. Plus, and the radius is plus radius. And radius is from this current class. Then lastly, we can do a public string toString. And you see here, it's saying add at override annotation. That's because what we're doing is overriding our superclasses method, the toString method. All right. So now what I want to do is return, I can call super.toString, that'll get that whole string from our superclass, plus additional information, radius plus radius. And so what this is doing is overriding our superclass method. We're saying, hey, if I have a circle, don't call the superclass method, go into here, and from there, I will call the superclass toString, but also add some additional information to it specific to this circle. All right. So I could override any method from our superclass. If I wanted to override the get field method or the set field method, I can from a subclass. All right. So let's see what the difference is. So let's create two types of objects. So let's create a geometric object. Geometric object, geo equals new geometric object. Now I want to pass in the color, say black, and its field, so true. All right, I create a geometric object. Let's create a circle. Circle C equals new circle. And I just want to pass in the radius, which is 5.5, okay? Now what you'll see is if I call the toString method for these two objects, they will be slightly different because my circle overrides the geometric toString. System.out.println geo.toString and system.out.println c.toString. So when I call these, again, c.toString is going to go to circle. It overrides the toString method of geo, and so it's going to go here. Whereas geometric object has its own toString down here. So if I run this, so create on Monday, March 1st, 10:41 a.m. Color is black and field is true. For my circle, it was created on Monday, March 1st, 10:41 a.m. Color was white, field is false. Those are the defaults for the geometric object. But it also adds radius 5.5. So it called the overridden method. So let's make that a little bit clearer. I don't need that one. So let's run this again so you can see the difference. So the first one is the geometric object toString, and it just has these two lines. But in Circle, we overrode that method, and we added an additional line to it, radius 5.5. So basically, that's the benefits of overriding methods. You can override the method of a superclass if you want to add additional information to it. Okay, so that's method overriding. The last thing we're going to talk about real quick is method overloading. And so what's the difference? Overriding is providing a new implementation of a method in a subclass, which is what we just did. Circle overrode the toString method of geometric object. Method overloading, on the other hand, is defining multiple methods with the same name but different signatures. Right? Method overloading, two methods with the same name but different parameter lists within a single class. And the Java compiler would determine which one to use. So I have another example, but I can use Circle. So if we look at Circle, Circle overloads the constructor. The first constructor has no parameters. The second one has a radius. The third one has 3 parameters, right? But they all have the same name, Circle, but different parameters, right? So when I go to create a Circle object, based on the parameters I pass in, it will create different, or it will call different methods as a result. So right here, I pass in a 5.5, which is a double. So it's going to go to this constructor. But if I pass in a 5.5, black, or let's say gray, and a true, now it's going to go to this constructor, right? So if I run this, it's going to say gray, filled, and true, right? If I pass in nothing, it's going to go to this constructor. And let's just set for this radius equals 0 for this purpose. So if I run this, you're going to see, I have error, semicolon. You're going to see radius equals 0. It's going to go to this method right here. So method overloading, say for example, you have a method that you like the name of it, right? And it does the same functions, but you want the ability to pass in different parameters. So say, for example, I have a method that just returns the max of a couple of different numbers. I can create 3 different methods, all named max, but different parameters. So this one takes in an integer and an integer. This one takes in 2 doubles. This last one takes in 3 doubles. But each one is returning the max, however the parameters change. And again, the compiler would decide which one to use based on what you pass into the methods, okay? So that's method overloading and overriding. Remember, method overriding is a subclass overriding a method of its superclass. So Circle overrode the toString method. On the flip side, method overloading is when you have multiple methods with the same name, so in this example, max, but different parameters, okay? And that can come in handy, again, if you have methods that are doing the same kind of functionality, but you have different parameters you want to pass to them. So if I have 2 doubles versus 3 doubles, right, I can still call my max method and return the max of those 3 numbers. All right, any questions? Method overriding, method overloading. This will be uploaded. Hopefully, I will get to it tomorrow. And it will be uploaded to the website and the YouTube channel, as well as I think the lectures from last week will be uploading as well tomorrow. Any questions?
No, sir.